Regarding space and Mars, which is exciting though, I think. So I would like to show you something. Why space exploration? We had these three questions going on, and I asked you to think about past space explorations, present, and future. And so I'd like to hear, is there anyone who can comment on that? Because I told you last week to think about this and to come up with something, like have you, to research it and to just know a little bit about space exploration and what were some of the launches that we've had in the past, and what we will have in the future. Do I have any volunteers? Or maybe you would like to say something about number one, where you think how it feels to be in space, or yeah, number two, I said just now. And number three, maybe the benefits of space explorations or risks. Who can comment on that?
Can I try to answer number two?
Yeah.
From what I hear and what I know, the astronauts will checking Mars planet. The purpose is to know if we human can live in that planet or not.
Yes. Very good. Thank you, Shelmia. Thank you so much. That's really cool. Yeah, and then it's gonna take place in 2024, where we're going to the moon. Yeah. Very good. Thank you. Anyone else? Anyone else would like to respond to that? No? Okay, I'm going to show you something. Basically, just now, I placed the link also inside your, what is that called? Your Unit 3 schedule. So understand now, guys, that I already in Moodle already uploaded all your tasks. So that means if you look at Moodle, you will see literature, the Odyssey, and then underneath you see Unit 3, listening and speaking, and then under that, Unit 3, reading and writing. Now, under listening and speaking, I already placed the instructions and criteria for the lock and the speaking test, and the ebooks and the test. And so I did for reading and writing, the journal criteria, ebook activities, and test. And so that means that jangan upload tugasnya di situ, tapi itu hanya kriteria penjelasan dan supaya kalian diingatkan kembali kapan harus dikumpul. Oke? Okay? Tapi semuanya di-submit di dalam Google Form, ya, ingat itu. Now, for the Unit 3 schedule is uploaded in Moodle. Di paling atas, you will see it. And nanti untuk link penilaian supaya kalian bisa tracking apa yang udah dikerjakan, apa belum dikerjakan, atau hasilnya apa. Nanti kalian bisa tracking sendiri persis ya dari setiap tugas. Itu juga nanti Miss Sylvie taruh di paling atas. Jadi di paling atas ada academic calendar, ada Unit 3 schedule, sama nanti ada grading form. Oke? Okay? Jadi semuanya paling atas, sama dengan ebook, listening, speaking, ebook, reading, writing, supaya diakses lebih gampang. Okay? That's all going to be up. Now, if it comes to extra information like PPTs, or I did Google Slides, or extra information or links, I placed them in our Unit 3 schedule. I didn't put them in the Moodle because I saw that sometimes it's a bit hard to access. So and because it's all links, I placed them in our Unit 3 schedule exactly where we have those topics. So it is important that you access your Unit 3 schedule frequently, because that one is basically your overview of what you're doing for that semester. Okay? And I also placed the links in there. So I've just now also placed the link for literatures are in there, and also just now placed the link for an access on the topic of space. So I'd like to share with you. Now I can show you, right? This is your Unit 3 schedule. And here I just put in the link for NASA Space Place. So if you would click it, automatically it comes out. You see that? And then you just click it one more time, and then you will be in the site. Like for the literature, we have that, and for extra information, GS means Google Slides, yeah, not PPTs, but Google Slides from Google. So that is GS is for literate devices. Then I have another document on literate devices, which is important for literature. And then paling bawah itu juga ada ini an opinion writing speaking summary because you guys are writing an opinion paragraph, dan ini di dalam sini ada contohnya outline untuk opinion paragraph sama penjelasan mengenai opinion paragraph. Jadi ini penting sekali dibaca, ya. Dia kasih structure paragraphnya sama penjelasannya. Oke, jadi semua materinya sebenarnya udah ada ya. Now, I would like to show you a few things. So this is the site for NASA Space Place, which is it's really cool because you can basically find anything on the topics, the missions, anything that they're doing right now at this moment for NASA and for what's going on for anything with space exploration. And you can just kind of go through that and figure out by yourself. I placed this link in your schedule. There's another thing I want to show you is the rovers that have been sent. In the past, we've had, let me see, 5 rovers that have been sent to Mars. These are the ones that have been sent to Mars. Yeah, look at that. How cool is that? The first one that was sent was called Sojourner. And that one was sent and landed on the moon in 1997. So it landed in 1997. Yeah, and then we had, this is Sojourner. So you could look over it if you want. Then we had another one. There were 2 sent there were 2 that landed in 2004. Those are Spirit and Opportunity. Spirit and Opportunity landed not on the moon, yeah, to Mars. I'm wrong. So everything was sent to Mars. So Spirit and Opportunity landed on Mars in 2004. Yeah. And we had another one called Curiosity. Now, by the way, Opportunity battery died down last year. So Opportunity broke down, which was actually supposed to last for only a few months. But Opportunity ended up lasting for years, right? 15 years or so. After Opportunity and Spirit, we had Curiosity in 2012. Curiosity landed on Mars in 2012. See that? And this year in 2020, we had Perseverance sent. That was several months ago. We had Perseverance that was sent to Mars, and Perseverance will land in February of this year. So next month, the Mars rover Perseverance will land on Mars. That's cool, right? So I watched the launch of Perseverance 8 months ago, and I'm definitely gonna watch the landing of Perseverance on Mars. That's so cool, guys. We can watch that live. You know, that's really that's just legit. Okay, I don't know about you, but I get hyped about that. It's really, really cool. So what we're going to do now, I would like you to look at Artemis. Artemis, Humanity's Return to the Moon. Artemis is a program where in 2024, 4 astronauts are going to go to the moon, 3 men and 1 woman. And they're there to stay. Yeah, they're going to stay there for 2 years. And then the plan is after 2 years to continue to Mars. Now, the trip to Mars will take 30 years. For a robot or for a rover to get to the moon only takes 9 months. But for a human, it takes 30 years. I think they're working on a way for humans to go to Mars that will take less than 30 years. But for now, it's 30 years. So the crew that will go to the moon and after 2 years go to Mars will definitely not return back to Earth. So their trip will take around 30 years, and then they're there to do research. So it's very immense because they will have to say goodbye to their families and really leave everything behind just for a mission. Yeah. So definitely going to the moon to learn. Yeah. That's so immense, you know, and the whole counting on the moon and Mars is different in time. How are we going? Yeah, they're going to build sustainable elements on and around the moon that allow the robots and astronauts to explore more and conduct more science than ever before. So exploration ground system, space launch system, and Orion. And then they also have Gateway, lunar landers, and Artemis generation space suits. All that is built, all that is studied and done, it prepares for the launch. Yeah. Okay, I'm going to show you this video. I hope that it works. Yeah.
All engine running.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
Very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing?
This system is capable of being the catalyst for deep space missions
we need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water, and we separate an oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and onto Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going.
We're going.
Okay, Nasaya. So basically, if you want to look at the latest updates or anything else, you can either go to the site of Artemis, but you can also go just to the link that I gave you guys, which is NASA Space Place. Okay? Really cool to know what's going on. Now, this is what we are going to talk about, yeah? This is exactly what you and I are going to talk about in the sense of what about space exploration? You know, what is good about it, but what are the drawbacks? You know, like there must be dangers and a lot of strengths. Can you imagine that if you would be the one that is going to go into space and that you're going to go to the moon and then stay there for 2 years and then go on to Mars, to a place that no one has ever been. And then you know that you will never return. So these people that are basically going to go in 2024, they will have to say goodbye to all their families and friends, and they know they will never return back, you know? And even for the moon people, the last time we had someone go to the moon was the first time. That was in 1972. That was the first time humans went to the moon. It was the last. We've never had it before. So 3 years from now, it will be the second time people will go to the moon. Super, super exciting. Is there anyone who would like to comment? No? Okay, then we're going to continue with the next page, yeah? So do the video. We already did listening 1 with the vocabulary, right? Right, I'm gonna skip this part and straight go into the into the answers. So I'm gonna simply ask some of you to annotate on this. Is there anyone who would like to annotate for me? Oh yeah, class secretary of IPS 1. Who's the class secretary of IPS 1? Guys, hello, hello.
Yes, miss.
Who is the class secretary of IPS 1? Shelny, can you tell me Shelny, what grade are you? IPS 1 or 2?
I'm IPS 2, miss.
2. Who's the class secretary of your class?
Carissa and Karin.
Okay, Carissa, can you annotate? Why is there no response, people? No response means absent, yes? Oh. Okay, Shelny, could you do it for me? Could you annotate for me? You have
I never tried before.
No? Would you want to try?
Okay.
Yeah, you're open on your laptop, right?
Yeah.
Yeah, I can see because your screen is big. If it's on the laptop, it's okay to do it. So just try to click the annotate, and then you have this for text, and then basically if you explore it a little bit, you get good at it, but it's just typing in the words. We're gonna start with number Number 1, give me a sec. Okay, let's start with number 1. Oh yeah, I need to open. Wait. I need to open your names. Okay, I'm gonna ask Carissa. Agung Carissa, can you please tell me what number 1 is? Carissa? Absent, yeah. Okay, we go to the next. Karina, are you Karina?
Yes.
Can you answer number 1?
Satellite?
Yes, I would appreciate it if you read the whole sentence.
Oh, okay. Machine that is sent into space and goes around Earth and is used for radio, video, and other electronic communication.
Awesome. Thank you very much. Number 2, we go to Abraham. Yeah, very good, Selny. Good job. Okay.
Yes, miss.
Abraham, can you do number 2?
Fragment.
Read the whole sentence. Abraham, read the whole sentence, please.
A piece of something that has broken off something larger. Fragment.
Okay, thank you. Number 3 is for Amanda.
Damage, physical harm that is done to something.
Yeah, awesome. Yehuda? Yehuda? Shannon? Shannon? Satya? Good morning, Satya. Yolanda? Good morning, Yolanda. Kalista? Kalista Natania, good morning.
Yes, miss.
Can you please do the next one?
Yeah, okay. Track to follow the movements of something.
Yeah, thank you. Gabriela Sabrina? Sabrina? Grace? Good morning, Grace.
Yes, miss.
Can you please do the next one?
Orbit, to travel in curved path around a much larger object such as the Earth or Sun.
Yeah, very good. Thank you. Okay, and then we've got number 6, spacecraft, the vehicle that is able to travel in space. Yeah, I would have to scroll down, so give me a sec because we would have to clear it, yeah, and then scroll first. Okay, now we can continue annotating. So number 6 is spacecraft, vehicle that is able to travel in space. Number 7, particle. Particle, which is a very small part of something. Yeah, 7, that's 7. 8, debris. Debris, which is the pieces of something that are left after it has been destroyed. So 8 is debris. 9 is collide. To hit something that is moving in a different direction. So when it collides, two objects hit. And number 10, cooperate, to work with someone else to do something that you both want, would be to cooperate. 9 is collide. 10 is cooperate. Yeah, please check your answers. Are there any questions about this? About the vocab? No? Shalini, you're doing an amazing job. Thank you very much. You're awesome. Such a help. Okay, so now I'm going to clear it, yeah, because otherwise I can't turn the page. We continue with the next part, which is previewing. In the video you saw and heard why previewing is so important, right? To build a focus through understanding what we look at that topic, right? The topic, and then know the purpose of the audio, and therefore know to focus on what to listen for and how to take notes. Let's listen to this. This is pausing. Okay, this is not good.
When NASA announced in 2011 that an old weather satellite, a 6-ton piece of space junk the size of a bus, was falling back to Earth, people worried. Scientists knew when it would fall, but not where. As it turned out, it came down harmlessly in the Pacific Ocean. But this made us wonder, how much space junk is up there? And are we in danger?
Okay, so this is basically like the beginning part of the audio. And so the first question was, how much space junk is there? I'd like to ask Bima Isa, can you please answer that?
Yes, miss.
What's the first one? A.
How much space junk is there? There are thousands of there are thousands of space junks.
Yeah, it's like so much, I don't think they even know anymore, like a lot. And what about B, Bima? Is space junk dangerous or not?
It can be dangerous to spacecraft, and it can fall back to Earth, especially at 8 kilometers per second, I think.
So you would consider that dangerous or not so?
Dangerous.
Yeah, exactly. Thank you so much for your quick response. Appreciate it, man. Okay, what we're gonna do now is I actually wanted to just simply go over the main ideas and figure out. I don't know if everybody has listened to the audio. Of course, was the purpose for you to have listened to it already. I'm gonna turn it on one more time, the audio, for those who haven't gotten a chance to do it. You can do it right now, yeah?
When NASA announced in 2011 that an old weather satellite, a 6-ton piece of space junk the size of a bus, was falling back to Earth, people worried. Scientists knew when it would fall, but not where. As it turned out, it came down harmlessly in the Pacific Ocean. But this made us wonder, how much space junk is up there? And are we in danger?
Well, we call it orbital debris, not space junk.
That's Michaela Johnson, a scientist who studies debris in space.
Most of it's created when satellites collide or explode. 2 recent events created 1/3 of the debris now in space. In 2007, an old Chinese satellite exploded. And in 2009, an old Russian satellite hit an active American satellite.
NASA tracks 21,000 large fragments more than 10 centimeters in width, or the size of a large apple. But there are 500,000 smaller fragments, the size of a grape, that we can't track. and the number of tiny particles less than 1 centimeter could be in the hundreds of millions. All these fragments orbit the Earth in a giant debris cloud. We're looking at a map of the debris on a computer screen.
So this is the Earth, and you see here, each dot is a piece of debris larger than 10 centimeters.
So far, no one has been injured or killed by space debris falling to Earth.
Most of it burns up long before it reaches the ground, but on average, one piece of space debris falls to Earth each day, usually in the ocean or a place where no people live.
A bigger problem is the fragments in Earth's orbit. These fragments are dangerous because they travel incredibly fast, about 8 kilometers per second.
That's 8 times faster than a speeding bullet.
At that speed, even small fragments can do serious damage to a spacecraft. And with each collision, more debris is created, increasing the chances of another collision. The problem will only get worse unless we can stop the creation of more space debris. And with over 1,000 working satellites in orbit, we may all feel the effects.
Our communication satellites, our weather satellites, our navigation satellites are all in danger.
That means our phone calls, TV signals, weather reports, and GPS map systems.
And it's not just a US problem, it's an international problem. Every country that sends a spacecraft or satellite into space, we're all part of the problem. So the international community needs to cooperate. We have to stop creating new debris and to clean up the debris that's already there.
There is some progress. Space agencies from 12 countries have formed an organization, the Interagency Space Debris Coordination Committee, to find a solution. But until then, we'll keep an eye on the sky, just in case.
Okay, great. So number 1, who would want to respond to that? No volunteers?
Number 1 is
B. Okay, number 1 is B, yeah? Collide or explode. Very good. What about 2?
Orbits Earth.
Yeah. A, yeah? 2 is A, orbits the Earth. Very good. What about 3? Falling debris?
B.
Yeah, usually burns up before it reaches the ground. Very good. 4, debris fragments in space are dangerous because they?
C.
Yeah, travel very fast. That's the thing. And 5, must cooperate to solve the problem of space debris.
International community.
Very good, B, the international community, because it's not just one country's problem, you know? I mean, like, what happens in space is like, I forgot what the word exactly is, but it's an international treaty that is signed by all the countries, you know? So that is something that actually is for everyone and should also be everyone's responsibility then, right? Okay, listen again, completed statement. So, a 6-ton piece of space debris the size of a bus fell to Earth in what year?
(2011).
2011, very good. So you can hear the difference, yeah? When we're looking for main ideas, those are the bigger points that can be developed, like when you write a paragraph, and details are the points that are more specific, yeah? I explained that already in the video. That's why it's very important for you to watch the video, because it's very precise on, I explain every concept. Number 2, 2 events created. What's number 2? Actually, it's C. 2 events created 1/3 of the debris in space. NASA tracks
21,000.
Yeah, very good. B, 21,000 large debris fragments that orbit the Earth. So much. There may be
C.
hundreds of millions of tiny debris particles. Oh boy, banyak sekali. Each day an average of, what would that be on an average day? That would be 1 piece. Yeah, 1 piece of space debris falling to Earth. Oh, that's scary. Space debris travels at how many kilometers per second?
8.
8 kilometers per second, though, people, second long. There are over how many working satellites in orbit around the Earth?
1,000.
Oh, so many. We need it though for the cell phone reception and all the things that we're doing, right? And number 8, how many countries formed an organization to solve the problem of space debris?
12.
12 countries, yes. Oh, we really also need a solution for this though, yeah? Awesome. So check your answers, see how many you've got wrong, yeah? If out of the main points, there were only 5, like I hope you had not more than 2 mistakes, yeah, or actually 1. And for the details, there were 8, so it would be great if you have not more than 2 mistakes out of 8, yeah? So check a little bit your options, like how did you do? If you sense, for example, that you're making too many mistakes, please let me know. You know, if you need extra exercise or whatever, let me know, okay? So check how well you did. Are there any questions about the main points and details? Okay, then we move on to making inferences, yes? Inferring factual information from context. In the video that was explained also, remember it's an educated guess about something that's not directly stated. So we are looking from the underlying meaning, connecting the dots. And so basically trying to get the information, factual information, looking at the context. So we have this part.
NASA tracks 21,000 large fragments, fragments more than 10 centimeters in width, or the size of a large apple. But there are 500,000 smaller fragments, the size of a grape, that we can't track. And the number of tiny particles, less than 1 centimeter, could be in the hundreds of millions. All these fragments orbit the Earth in a giant debris cloud.
Okay, so NASA cannot track most of the debris fragments because who knows the answer to this one? So it's not really stated, right? It's not really mentioned literally, but it's there though. If you, after you've listened to it and you kind of connect the dots, you can, you know, like listen between the lines. We would say read between the lines. You can't listen between the lines, but you know, listening between the facts or something. Who knows the answer?
Move too fast?
The answer, thank you very much for answering. Appreciate it big time. The answer is C though. They're too small. Not that they move fast, but the reason why they can't is actually also because they're way too small. And the keywords for that were size, tiny particles, and less than 1 centimeter. They're less than 1 centimeter. From those facts that we heard from what was said, we can conclude or infer that they can't track it because they're too small. Okay, let's try the second one. Guys, I'm almost done, yeah? I'm a little bit tight on time today.
So far, no one has been injured or killed by space debris falling to Earth.
Most of it burns up long before it reaches the ground, but on average, 1 piece of space debris falls to Earth each day, usually in the ocean or a place where no people live.
Okay, cool beans. People being hit by space debris. The keywords that we heard just now, check them if you have them correct, are no one has been injured or killed. It burns up mostly, and mostly it falls in the ocean where no people live. So looking at those factors, what can we infer?
B.
Yeah, true. B. Should not worry about it. Correct. Awesome. See, that's what inferring means. You're not literally hearing it, but it's there though, you know? Okay, let's do the third one.
A bigger problem is the fragments in Earth's orbit. These fragments are dangerous because they travel incredibly fast, about 8 kilometers per second.
That's 8 times faster than a speeding bullet.
Super fast. Okay, the keywords that we heard here were problem and fast. I don't know if you got that, but those are the 2 words that were very emphasized, problem and fast. What can we infer? Dangerous, what is dangerous to spacecraft? Anyone? What's the answer?
C.
Yeah, fragments of all sizes are dangerous because they're fast. Yeah, very good. Awesome. So that's what it means, yeah? In order for you to know, to infer, you need to get the facts and like correlating, connecting those dots. From there, you can come up with a conclusion or with a judgment like, oh, okay, so that's what it is. You will see the underlying meaning. Okay, we were in the video, I told you to be opinionated and to think about these points and to be able to express your opinion on it. And to do that at our Zoom class right now, and using P and PO or arrow. In writing, we use P, yeah, point, explanation, evidence, or PO with linking. In speaking, we call it arel, yeah, assertion, which is the point, the opinion, and then R for reasoning, E for example or evidence, L for linking back. But my apologies, my beloved students, awesome guys. I'm a little bit short on my time right now, so we would have to continue with that, but we will do this again next week for reading, because in every section there is this expression of opinion, which is important because it's a part of evaluating, reasoning, like thinking about all the information, connecting the dots, coming to a conclusion, and a judgment is a part of your cognitive level of evaluating. So it's important to do it. We will do it again next week with reading, which is kind of more or less the same topic. So we can lean into the listening and the reading at once, both, okay? Another thing that is on today's schedule is our video, which actually I wanted to do today in class, but that's impossible because of my error with my Zoom just now that I couldn't enter the class. So I'm going to ask you to do that today. Yeah, as you can see here for this week, there's a video comprehension. The link is already in your ebook. Yeah, so you can just open your ebook for listening and speaking, and then just go into the activity. This is an example of IPS 1. I will pop up the Google form, and here you've got the link. Just click the link and you will be able to do the questions. There are not many. There are only 5. It's only a little bit. Will take you like 5 minutes or so, not even 10, to do this. Okay, so please, if you have some time to do it now straight away. But at least finish it today fast. You have like 30 minutes right now. Yeah, you could like do it right now and then you got it over with. I want everything recorded today though. Okay? Watch the video. It's about space. Watch the video, answer the questions, and then if you have any questions, you can always contact me about anything that is unclear. Please also, if I've made a mistake in the ebook or in my forms, please let me know so I can fix it. Yeah, it's important for me that what I give you is done correctly, but I'm human. So please let me know if there is any error. Also, let me know if there's something you don't understand. I will make time to re-explain. Also notice that I've sent last week's Zoom meeting already in the WhatsApp group. So you can watch that if you would want to re-watch it with regards to the explanation of our projects. Also, I've already put the explanations on your projects for speaking and writing in Moodle. And I've also already uploaded the video for Unit 3 Reading 1. So remember, your post-study, yeah, before we end the lesson, important, your post-study for this week, just to give you as a reminder, will be to do the activities in listening 1. Your ebook, yeah, the activities are already there. I have opened all the activities, not like last semester I didn't, this semester I did. So if you want to work ahead, you can. If you want to continue all for Unit 3 at once, you are allowed to do that, okay? Only for post-tests and unit tests are closed, but for the rest, you can just work ahead if you want. But for this week, it would be listening 1 ebook, and the pre-study that you need to do this week for next week's Zoom meeting. Please watch the video of Unit 3 Reading 1, which I've uploaded this morning, and do the activities in your textbook, yeah? That's it. And don't forget literature, yeah? Read chapter 2, follow the literature. We will meet each other again tomorrow for literature, okay? Okay, cool beans. God bless you all. I will see you tomorrow. Yeah? Bye.